All right, guys, so this is section 5.4. I forgot to type that in. Solving radical equations. So it says here there are several ways, okay, there are several different types of equations with radicals. Focus on thinking about the problem and the best way to solve it, as opposed, okay, guys, to memorizing how to do it, okay? So here's some guidelines. You guys have 4 blank lines on your notes outline. Please copy this down. The first one is to isolate the radical, get it by itself. Remember, when we were solving absolute value, we isolated the absolute value. When we were solving for quadratic, we isolated the quadratic. So in this case, we are going to get the radical by itself. Step number 2, eliminate the radical. What is the inverse operation? If it's square root, the inverse of that, okay, to get rid of the square root is to square both sides. If it's a cube root, to get rid of the cube root, we are going to take the third power to both sides, okay? Cube both sides. Once all radicals are gone, solve like you would any other equation. Then step number 4, check your answer. Substitute it back to make sure the equation is true. So examples, we have, let's see, 1, 2, 3, 4, 5, 6, 7. So we have 7 examples altogether. So, and it says solve all of them. So step 1 says isolate your radical, guys. So what you want to do is we have a square root, 2y minus 1, and then plus 5 is on the outside equals 8. So first step, move 5 to both sides by subtracting. Then we have the square root of 2y minus 1. Make sure if it's under the radical, we want to double check to see if the radical symbol is long enough. 8 minus 5, y'all, is 3. Now, to get rid of the radical square root, we are going to square both sides. This is going to get rid, okay, the radical symbol and the power of 2, they kind of undo each other, okay? But again, you don't have to do all of that stuff right there. We just know that they're just going to undo one another. Then we have 2y minus 1 equals 9. Then we're just going to solve it normally. Add 1 to both sides. 9 plus 1, that would be 10. So 2y equals 10. Divide both sides by 2, guys. So 10 divided by 2 is 5. Then we want to plug it back in and check to make sure we did it correctly. Square root 2. We have y is 5. So 2 times 5. And then minus 1, this is all under the radical. Plus 5 is on the outside, question mark. Okay, 8. So under the radical, 2 times 5 is 10. 10 minus 1 is 9. Drop everything else back down. Square root of 9 is 3. 3 plus 5, yes, equals 8. So we can keep our answer. Number 2, similarly, first step, isolate your radical. So we are going to move the 9. So this is read 9 plus square root of x minus 1 equals 1. Now another way to rewrite this, guys, is the same as the original, is move the 9 in the back, because if it's an addition, it is commutative, meaning that you can move it back and forth. So this allows you to say, okay, yeah, I can move the 9. So square root x minus 1. 1 take away 9 is going to be negative 8. Square both sides now that the radical, it's all by itself. Okay, so x minus 1 equals negative 8 quantity squared is positive 64 plus 1 to both sides. 64 plus 1 is going to be 65. We do want to check to make sure our math is right. You can plug it in here or you can plug it in here. It doesn't matter because it's the same equation. So 9 plus square root 65 minus 1 equals 1, question mark. 9 plus 65 minus 1, guys, is 64, question mark, equals 1. Well, 64 square root is 8, so 9 plus 8 is definitely not equal to 1. So no, it's not true, and so that means we cannot keep 65. So now here's the reason why it's a no, guys. And our answer is no real solutions. No real solution, okay? All right, now let me explain to you why we can't keep the 65. When we isolated the square root, we had a negative on the outside, okay? Just like, remember when we had the absolute value and we had it equals a negative, and absolute value cannot be negative, therefore we write no solutions. Same thing with square root, fourth root, eighth root, sixth root, any even root. Even roots cannot have a negative answer, so that's why we put absolute value around it. In this case, these are numbers. We can't just go and stick an absolute value around these. So if you have an absolute value, can't be negative. Well, you can't have a square root be negative. So in this case, if you see that you have a square root and it equals a negative number, you can go straight to no real solution. Now, fourth root, okay? That's an even root. So if we isolate the radical and it equals a negative, then you can go straight to no solution. But let's try to isolate it first. So this one's read 5 times the fourth index or fourth root of 2m plus 1 minus 1 on the outside equals 14. So guys, you isolate it normally. There isn't anything special about isolation, okay? You add or minus first. Remember, if there's a fourth root, you write the 4 number right in the little pocket. So 2m plus 1 equals 14 plus 1 is 15. Next is going to divide both sides by 5. Ooh, 15 divided by 5. So that's going to be fourth root 2m plus 1 equals 3. Now it equals a positive 3, so we know we are going to be okay to have an answer. Now the opposite of fourth root, guys, is to raise it to a power of 4, just like that. So fourth index and power 4, they cancel each other out, so 2m equals 3 to the fourth. That's like 3 times 3 times 3 times 3, like that, okay? So that's 9. 9 times 9 is 81. So 81, so over here 2m plus 1. And you're just going to solve it as you would in pre-algebra. Minus 1 from both sides. 81 minus 1, guys, is going to be 80. Divide both sides by 2. So that's going to give you m is, oops, divided by 2, it's 40. Now we know it has an answer because when we isolate it, the root, it was a positive, oh, I didn't mean to cross that out. I meant to get a highlighter. A positive 3, and that's an even index, so we know it has an answer. So we can keep the 40. Example 4, cube root of 3y plus 1 plus 2 on the outside equals 0. Remember, cube roots can definitely be negative, so all cube root will have an answer, whether you have a negative number on the other side or a positive number on the other side, okay? So first step, isolate the radical by moving the 2 over, so 3y. Cube root of 3y plus 1 equals negative 2. Since this is an odd index, negative numbers are okay. So to undo cube root, we are going to raise it to a power of 3, okay, just like that. So that will allow us to have the radical and the power, they undo each other. Negative 2 times negative 2 times negative 2 times negative 2, guys, that's going to be a negative 8. So 3y plus 1 equals negative 8 minus 1 to both sides. Okay, so 3y equals negative 9. Divide both sides by 3. Y is going to end up being a negative 3. And yes, we can have that answer because cube root will not have any issue at all with negative or positive. Now we have example 5. The quantity of x plus 3 to the half power plus 2 equals x minus 1. So when we see the rational exponent, which is a half, oh, why does it keep doing that? I meant to highlight it. A half, then we want to write it as a square root. So this is going to get written as x plus 3 plus 2 equals x minus 1. So we are going to minus 2 from both sides. Okay, isolate your radical. So square root x plus 3 equals x minus 3. Now we are going to square both sides. This is going to be a little bit more difficult because these right here are 2 terms. When you square both sides, we need to FOIL that out. So write it out twice like this, and we are about to multiply. So x plus 3 equals x times x is x squared. There's are going to be negative 3x. This is also negative 3x. Negative 3 times negative 3 is now going to be a positive 9. Combine like terms, so x plus 3 equals x squared minus 6x, and then plus 9. Now, because we have a quadratic here, what that means is now we have to set one side equal to 0. So I'm going to move everything to the left, okay, and then towards the right side. So the left side will now say, hey, that's going to be 0 now. Cancel, cancel. Because we do need to factor. Anytime you have a square power, we have to make the equation equal to 0. So we can try to solve it by factoring, by completing the square, or using the quadratic formula. Negative 6x and a negative 1x is now a negative 7x. 9 take away 3, students, is going to be a positive 6. Okay, so your two factors are x minus 6 times x minus 1. At this stage, guys, in your math career, we should be able to factor that pretty quickly. So take each factor, set it equal to 0. We are going to come up with x equals to 6, x equals to 1. Now we want to make sure we can check it in here, okay, to check. So, okay, so square root, let me just copy that back down. X plus 3 plus 2 equals x minus 1, question mark, okay? So mental math, when we plug 6 back in, 6 plus 3, that's going to be square root of 9, okay? And then over here, 6 minus 1. I'm sorry, minus 1, and I wrote plus 1 right there, minus 1. Okay, so this is 3 plus 2, which is 5, and 5 equals 5. So we can keep the 6. Same thing with the 1. Let's check 1, square root of x plus 3, so x is 1. 1 plus 3 is now 4, plus 2 equals 1 minus 1. So let's see what's going to happen. Square root of 4 is 2. 2 plus 2 is 4. 4 is definitely not equal to 0. So out of these two solutions, guys, we can only keep one, okay? So this one we cannot keep, but this one we can.